Hi guys, this is Franco from my IT and cybersecurity journey. Today we will be going over scenario 1 of my CKAD course here on YouTube on getting you ready for the Certified Kubernetes Application Developer exam slash certification. Um, this will be the first lab. They are ranked in order by the numbers, so this being lab or scenario number 1 is the easiest. Each scenario consists of multiple steps, and let's get on with it. So, just to read over this scenario, welcome to your first day as a Kubernetes cluster administrator. Your scenario will be Angelica just joined the front end team at your company. Your job as cluster admin is to create her isolated development environment with proper resource controls so she can't accidentally consume all cluster resources, right? This is a common real world task that ensures developers have isolated workspaces, right? So for her testing, she needs her own namespace. She can't monopolize cluster resources, so she can't have a pod hogging all of the resources for a node. Uh, we're going to make sure that her pods get sensible defaults, right? So she doesn't have to always set the CPU and memory request. And also, the quota will also take care of, making sure that if she were to set them manually, she doesn't do a belligerent amount. And we're also going to make sure that she has proper identity in the cluster. Um, so these are the learning objectives. Feel free to pause here and read through them and relevance to the exam. Let's start. So first we're going to create a namespace named dev-angelica with the following labels. So for creating items imperatively in Kubernetes, the quickest way we can do this, again, because the exam is all about speed, is kcreate-h. That will show you up here the available commands that you can run the kcreate kubectl create command on. Again, I'm only using K because I have an alias set for it in my bash rc. So if we go to my bash rc and go to alias, we will see here, somewhere here, there, K is equal to K kubectl. So we can do that. So that'll be that. And so we'll do K create. You can use the short name, which will be ns, and after you specify the object you want to create, you can run the -h command again, and it'll give you options. So as you can see, we can't really specify labels imperatively, so what we have to do is we're going to grab the name here, and we're going to paste it. Whoops. I'm going to copy the name here. Okay, I think I copied good. And so then we are going to run -try -run equals client. What this does is that it actually doesn't create the object. It just like prints it if it was good. So if you were to just run this, it would tell you that so far your imperative command looks good, and if you were to remove the dry run, it would actually create the object. But since we did a dry run, it's not going to create it. Then with the -o flag, you can specify the output to be YAML, which we want because we are wanting to create this, but we have to add the labels that our requirement is asking for. So we're going to do this. And so labels always go under metadata. And so we're going to add two labels. Team is front end, and the environment is dev. So that's done. Then to create it, we're going to do kcreate, specify a file, ns.yaml. And so that takes care of the namespace part. So now what we want to do is we want to go into the namespace to create the object for the service account. So one thing that you're always going to want to do on the exam is run kconfig set-context -current -namespace, and you are going to put the name of the namespace that you are wanting to always go into or always act upon when you run your commands. So what this does is that it changes your context file's namespace so that any actions you commit are always going to be done under the dev-angelica namespace. So what this does is save you time when creating objects imperatively so that you don't have to specify the -n flag and then put the namespace every single time. You can just create it and omit that. And for this exam, you only get 2 hours, so every second and every minute counts. So to create the service account, again, you can create the service account. If we run dash imperatively, if we run -h, you can see here service account exists here. The short name for a service account is SA, so we're going to do create SA. If we run -h, we can see the options, and the requirement just asks for us to create it, nothing else. So we're just going to create service account with the service account name, which is going to be Angelica-SA. And so if we do kget SA in the Angelica namespace, which we know we're in because if we do kget pods, we see that the dev Angelica namespace contains no pods, but our service account exists. So let's do the check. Step 1 is validated. Step 2, we're going to set resource limits and quotas. So feel free to read the Kubernetes documentation on what a quota does, but basically it sets a quota per se on the namespace level. So to create it imperatively, I believe you can actually use, you can do create-h. And so we're going to call it dev quota, and it's going to be in the same namespace. Again, I don't have to specify that because I switched my context. And so as we can see here, it's asking for us to create hard limits on requests. So basically what hard limits are, you can run kexplain quota.spec .hard. And so it goes over it here very briefly, but it's a hard limit for each named resource. So basically, like for each resource that she creates, so she can only create up to 10 pods in the namespace, and she can only request a total of 2 CPUs and 2 gigabits of memory for objects in the namespace. So let's go ahead and create that. So we're going to do create quota. Again, -h just to see our options right here. Some of your most useful flags are always going to be down here at the bottom. So we're going to call it dev quota. And we're going to do hard. And so our first one is going to be key1 is equal to value1. So our key is going to be request.cpu. And our value for this is going to be 2. Then you can do a comma separated list. So we're going to do request.memory. And it's going to be equal to 2 GIs. And then we're going to do pods, which is going to be equal to 10. And so we can do a dry run real quick just to make sure that it actually will take our command. And so if you want to see the YAML, as you can see here, this is what it would look like. And so we can look at the documentation. Just a tip for the exam, when navigating the documentation, what you can do is you can always use this to search for the object you want to get YAML for. And once you're actually on the page, use Control-F and type in kind, : and it'll show you example YAML that if you were to have to create it declaratively, which you do for some resources, you could just go ahead, copy, paste, and then vim it. So let's get this created. Let me go ahead and delete this. And so now if we do kget quota, we can see here, she can only request up to 10 pods, 2 CPU cores, and 2 gigabytes of memory. So, and it's named dev quota. Next, we're going to create a limit range. So let's see if we can create this imperatively. Limit range. I don't know the short name for that. Alright. I don't believe we can create a limit range imperatively. So, what we're going to do, what I just explained, we're going to look up limit ranges here. And so after that, we are going to Control-F kind. We have an example of a limit range here. We're just going to go ahead and copy this because as we can see by the question, it's asking us to set the limit range here. And so as you can see, here it tells you what each one does. We can set limit ranges either on the pod or container level. This is very important. Make sure you pay attention when you read questions for what they specify. If you want to set them at the pod or container level. And so what we'll do is we're going to do vim lr.yaml. Let's see. So we're going to rename the limit range. So it's going to be dev-limits. Go back here. And so it's asking for a default on the limits for 250 CPU. So we can just delete this. A default request of 100 millicores for the CPU. And so we're going to have to add memory here. So for the limits of the memory, it's asking for a default limit of 256 MI, and then for the request, it's asking for a maximum of 128 MI. And it's not asking us for a max, so we can go ahead and delete this. Since it doesn't specify it, what I will do is I will just leave it at container, and we'll create it here. Then we can run kget lr, kget limit range. And if you're ever wondering, like, what is the name for a resource? You can always run k api-resources, and so it'll have a couple columns. This will be like the resource name, the API, the short name if it has one. I forget what this column. Oh, if the object is namespace or not, and then the kind. So we can actually go ahead and run k api-resources, and we can grep for limit. Let's see what pops up. And so we can see here limit ranges. The short name is limits. It is a namespaced object, so it sticks to the namespace you created in, and then that is the kind for when we write our declarative approach in the YAML, which we can see here matches. So kget limits. We can see here we have dash limits. If you want to see the YAML of that real quick, you can always run this, and it'll show you the YAML of an object. Since it's just the only object, I don't have to specify the name, but if there were multiple, you would specify the name, and they would give you the YAML. So we can go ahead and check this. Next, we're going to set up our environment. So we're going to create a pod named nginx test in the dev Angelica namespace. So krun nginx-test. And so the way you, krun is basically like the imperative way for creating pods. Quickest way we can do that is we can run krun nginx-test. And if we do -h, again here at the bottom we can see the multiple options we can specify. So what we're going to do is we're going to specify the image, which we have here in our requirement. So this is going to be our image. The service account, we are going to have to go ahead and add that. We're not going to specify resource and request limits because, again, like the previous step described, limit ranges set the defaults for us if we don't define them at the pod level. And so to add the service account, I'm going to go ahead and do this manually. So I'm going to do dry run equals client show YAML, and I am going to send it to the nginx test.yaml. And so to add a service account, you can always use this kexplain. This is a quick way to kind of get an idea of how to add stuff to the YAML. So I can run pods.spec, and then I can add the recursive flag, and it'll kind of list everything for me. What I would want to do here is grep for service, and I can see here service account. It looks to be under the pod spec. So that's what we're going to do. We're going to go ahead and when we go into the YAML, I'll show you how that looks, right? So we have the pod, kind is pod, and then the spec. So it'll be here. So I'm going to add it here at the bottom because this is at the pod level. So we're going to do service account, and you just specify the name. We go here and actually run it. I'll show you guys. You can also confirm by doing this. You can do pod.spec, and to check that service account actually is under spec, we can see here. It tells us what it is, and you know, how to write it in the YAML. It's just asking for the field service account followed by a string. So we're going to go ahead and add it. And so down here we have service account, followed by a string, which is Angelica-service account. And we're going to create that. So now we do kget pods. We can see our pod is creating right now. Let's go ahead and run it here in a little bit. We're going to verify that the pod is running has a default limits and requests. So the way we do that is kget pods-o YAML grep -c5. This is just how I do it. And I want to grep for requests. And so we can see it is requesting. The limits are 250 and 256, and then the requests are 100 and 128, like our limit range defaults that we set in the previous step. Now attempt to create a pod named GreedyPod that requests 4 CPU. It's not asking for an image. We can run with any image. Okay, run. We're gonna call it greedy dash pod dash dash image. I'm just gonna use the Nginx image. And you used to be able to add requests and limits imperatively. You're not able to anymore. So what we'll do is we're gonna do client shell YAML. I think that was deprecated in Kubernetes 1.29, and we're doing greedy.yaml. And so here at greedy.yaml, we're gonna specify at the pod level. So if we run, if I actually go back here, come on, man, what are you doing? All right, go back here at kexplain pods.spec.resources. I'm going to be able to see, okay, claims, we're not looking at that right now, but we're looking at limits and requests. So this is what I would do. And of course, you can click on the link to read about it. So we're going to go ahead and edit it, greedy.yaml. And so we're going to add a section here. I like to do it from the bottom. So for resources, we're going to do requests for CPU, for course. 4M, or actually you can just do 4. And so that'll request 4 cores. And I don't think that's going to ask anything else. Okay, create -f. We should get an error here. So we can see here, error when creating key.yaml is forbidden. It's exceeded the quota, which is true, right? Because we set our limit of the quota, get quota. Our limit on how much a pod can request. So each pod can only request up to anything between, all pods really can only request up to 2 cores. So this pod can't be greedy and take 4 cores up because it has to request something between what's available and 2 cores. And so that is that. We can go ahead and check that. And I believe that's it. So you've completed the lab. Thank you guys so much for watching. Again, you can go ahead and read through this. I left tips here for you guys to kind of go through, and you know how much of exam relevance this has. So next, we'll go over config maps, secrets, security context, and network policies. Thank you so much for watching, and have a good day.